let's start with the bottommost layer of the OSI model, which is physical layer. Okay. Yeah, the first layer. Yes, we have finally started. Okay. Physical layer is the bottommost layer of the OSI model. First layer from the bottom. What are its responsibilities? It's one responsibility. It's not services, it's responsibility. It is responsible for establishing an actual physical connection between two devices. Two or more, but two basically. Actually, responsible for establishing actual physical connection between two devices. Okay? Understood with this? Okay. Third summary. What are the devices? Modem, repeater, hub, cables. Cables are not devices, but consider NIC, but only partially. NIC partially operates at physical layer. Why? NIC is the one which transforms electrical bits into signals, right? That is the function of physical layer. But NIC also does populating source MAC and destination MAC. That is the function of data link layer. That is the reason it's partially physical layer, partially data link layer. Okay? Okay. Now, let's start with services of physical layer. Services of physical layer. Okay. What's the first service of physical layer? Basic bit by bit transmission. First service is bit by bit transmission. Physical layer is responsible for converting the data into bits and then transmitting it one by one. That is the main function of physical layer. Okay? Now who does it? It is just computer who does it. Not physical layer. It computer, but computer layer, but computer is nothing but physical, right? So it is a device. Physical layer is responsible for converting all the data into bits. Second, I told you just now, it is also responsible for signal transmission. Signal transmission. Physical layer is also responsible for getting the bits, converting the bits into signals, right? And sending them out. NIC, it does the same. Okay? Getting the bits and converting them into signals and sending them out. So now converting bits into electrical signals. This is for copper wire. Converting bits into optical signals or optical pulses. This is for optical fiber. You can also call light pulses. Okay. Converting bits into radio waves. This is for Wi-Fi. Air, bro. Okay. Got what signal transmission? There are two forms of signals: digital signals, analog signals. I explained you already. Digital signals, it is represented by square wave. Analog signals are represented as sine waves, sinusoidal waves or sine waves. This can represent discrete values 0, 1, point, 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 point. This represent continuous values 0, 0, 0.5, 0.6, 0.7, kind of, right? Analog signals. And what is third major function? I told you modem operates on physical layer. That is a function. Physical layer is responsible for modulation and demodulation. If you don't know about this, or if you have forgot this, go to my channel. Modulation and demodulation. Modulation is nothing but converting digital signal into analog signal, converting the analog signal to digital signals, or vice versa. Right? Right. Fourth thing, transmission modes. This is also done. Physical layer is responsible for determining the direction of data flow. That is what called as transmission modes. Simplex, half duplex, full duplex. Simplex is nothing but one can be sender, one can be receiver, not vice versa. Half duplex means both can be senders and receivers, but not at the same time. And what is full duplex? Both at the same time. We have simplex, we have half duplex, we have full duplex. Physical layer is the one which decides what is the direction of data flow, right? Fifth one, okay. Data rate. Data rate is nothing but, suppose, okay, you are very lucky that your device is supporting 200 Mbps incoming of data. Okay, but not all devices support 200 Mbps incoming of data or outgoing of data. Some devices only support 10 Mbps, example, 10 Mbps. So physical layer is responsible for actually controlling the data rate for devices at the both end. Suppose the sender has 100 Mbps of speed, not speed, bandwidth. Suppose the sender is sending at the rate of 100 Mbps. If the receiver supports only 10 Mbps, the data gets lost. So physical layer makes sure the clock is synchronized in such a way that it will send the data very, very slowly. Nothing but NIC does that, but physical layer, it controls the data rate, so which is beneficial for both sender and receiver, so that no data is lost in the between. Understood? The last function, very important function. In your colleges they ask, okay, the last function, encoding and decoding. See, in real life, encoding and decoding is different from physical layer encoding and decoding. In real life, encoding is nothing but changing the format of data from one form to other basic form so that two devices can agree on it. Okay? Yeah, this also means same but not absolutely same. So here encoding is nothing but converting bits into signals, and here decoding is nothing but converting signals into bits to understand data for the computer to understand. Why do we do this? I explained you while explaining modem, I guess. Modem, yes. Bro, if because the copper wires or optical fibers or telephone lines, these are just cables. These people don't understand 0101, they understand only signals, right? So that's the reason someone has to be there to convert bits into pulses or electrical signals or optical signals or analog signals, anything bro, anything. Okay, that is actually done by NIC. network interface card. Okay, but here physical layer. Okay, so on copper wires, you know, when you touch a copper wire, you get current shock. So it means it's carrying electrical signals and optical pulses, light on off on off on off on off. If light is on for certain period of time, it means it's 1. If light is off for certain period of time, it means it's 0. Simple. Okay, optical pulses. Telephone lines, these prefer analog signals. Now NIC converts bits into digital signals. Here comes modem, who is Badsha, who does modulation, converts digital signals into analog signals, and then it can go to telephone lines. Undersea cables. Undersea cables also support, also need analog signals, not digital signals. Undersea cables, okay? Yeah, because undersea cables are huge. If they do copper wiring, right, it will be very costly. Just are simple telephone lines, okay? Now, how this is being done is the question.